Next, we want to talk about logarithms. We just talked about exponential functions in the form y equals a to the x for all positive values of a, where a is not 1. The horizontal line test shows that this exponential function is 1 to 1, and that means it has inverse as an inverse function. The inverse function is called a logarithm. The equation defining the inverse of a function is found by interchanging the x and y, which we started with y equals a to the x. We interchange the x and y, we get x equals a to the y. Notice here that y is the exponent in this case. Have x equals a to the y is the exponent that a must be raised to get x. We call this exponent a logarithm, symbolized by log. The expression logarithm base a of x represents the logarithm in this discussion. A is the base of the logarithm. X is called the argument, and it's read logarithm with base a of x or logarithm of x with base a. We need to specify which is the a and the x being the argument. Logarithm with a function base a for all real numbers y and all positive numbers a and x, where a is not equal to 1. Now notice those are all positive numbers a and x. Log y equals log base a of x if and only if x equals a raised to the y power. Notice a logarithm is an exponent. The logarithm is the exponent. The expression log base a of x represents the exponent to which base a must be raised in order to obtain x. You must know this. In logarithm form, y, or f of x, the exponent equals the log base a of x. In exponential form, that's a raised to the exponent y equals x. So let's practice doing that transformation. Here we have logarithm form. Log base 2 of 8 equals 3. In exponential form, the base is 2, the exponent is 3, and it equals 8. Now we want to change this exponential form to log form. It's log base 1/2. What are we raising to the power? Of 16 is -4. -4 is the power we raise 1/2 to get 16. Log base 10 of 100,000 equals 5. That would be 10 then to the 5th power is 100,000. 3 raised to the -4 power is 1 over 81. Its log base 3 of 1 over 81 equals -4. -4 is the power we would raise 3 to get 1 over 81. Log base 5 of 5 equals 1. The base is 5, the exponent is 1, and 5 to the 1st equals 5. We have 3/4 raised to the 0 power equals 1. So the log, the base, is 3/4. That's what we're raising to the power. When we raise it, we get 1, and the exponent is 0. You must be able to do these transformations. We want to define some certain things. For all positive numbers x, if we just say log x instead of log of a base with x, it means log base 10 of x. So plain log x means we're using base 10. And then we have the natural logarithm. For all positive numbers x, if we just say ln x, that means log base e of x. Both of these things are important that you remember. Now we're going to evaluate these and come up with an actual number. Log base 5. The question is, what power, since the log is the exponent, the question is, what power do we raise 5 to get 5 raised to the second power? Oh, we raise that to 2. And what exponent do we raise 7 to get 49? Well, 49 is 7 squared, so the exponent is 2. What log do we raise 8 to get the square root of 8? Well, the square root is the 1/2 power, so the exponent here is 1/2. What power do we raise 2 to get 1/4? Well, that would be a negative because obviously we flipped it over to get a 1 over, and 4 is 2 squared, so this would be -2. What power do we raise 16 to get 4? So we have 4, 16 to some power equals 4. Well, that would be the 1/2 power because 4 is the square root of 16. What exponent do we raise 64 to get 64 to the -3? Oh, we raise it to -3. Now remember, this means base 10. What power do I raise 10 to get 10,000? Remember, we just find that by counting the number of zeros, so it's 10 to the 4th. What power do I raise 4 to get 1? Well, to get 1, when I raise the power, it's always 0. What power do I raise e to get 1? Well, to get 1, it's always raised to the 0 power. What power do I raise e to get e to the 2nd? Oh, 2. What power do I raise e to get e to the -2/3? Oh, -2/3. What power do I raise 10 to get 1/1000th, or 1 over 1000? Oh, the 1 over means it must be a negative, and 3. It's also important to be able to change between exponential and logarithmic forms. Log base 4 of 64 equals 3. We're just doing more practice of switching those. We did some earlier. Let's do some more practice. The base is 4. The exponent is 3 to get 64. The base is e, since it's an ln. The exponent is -1, and that equals 3,679 10,000ths approximately. We want log the base 10 of 1,000 is 3. Well, here's the exponent, so this must be the base. So it's log base 36 of 6 equals 1/2. 1/2 is the square root. Square root of 36 is 6. Here's my base is 25. Exponent is 1/2 equals 5. Change this to log form. Well, it's ln, since it's base e, of 20 and 900ths is approximately 3. Exponent, log is the exponent. Power do I raise 7 to get 1/7th? It's -1. Remember, the log equals the exponent.